Just give me a second. Okay. Our variables are u, x, and t. Okay. Now we identified our variables. Now just use the assumption. The assumption is assumption is that the variable in the denominator and the values of denominators. You apply it as the following. Denominator, which is u, use the capital letters. As for the denominator, you can use the, yes, you can just also apply the capital letters. So you get ux of t, ux and t. Okay. Now, depending on the equation that you have here, del square u over del x square, or d. This one is called the del. Okay, del or d, whatever. Okay, a partial square u over partial x square, call it whatever you want, is equal to. You need to differentiate this one twice to the respect of x. So you'll get x double prime t. As for the another equation, it's partial u over partial t. You need to differentiate once to the respect of t. So you'll get x t prime. Okay, now you need to substitute this back to the same equation. You'll get x double prime t is equal to 1 over alpha square xt prime. This is the same equation, just written with the assumption. Now you need to divide by the assumption. Okay, always divide by the assumption. This is the assumption, divide on it. So you'll get x double prime over x, 1 over alpha square t prime over t equals to lambda. Okay. Now divide the page into 2, and you will get x double prime over x equals to lambda t of square t over t equals to lambda. Now solve this as following. Lambda x double prime lambda x equal to 0. As for this, you'll get t prime, then negative, sorry, no, there's no equal here. Negative lambda alpha squared t equal to 0. Now these are the equations that we're going to operate on our solutions. Now as for case 1, lambda is equal to 0. Okay, this will give you that x double prime equal to 0. As for this t prime equal to 0, integrate for both sides, you'll get t is equal to c 1. Integrate for both sides, you'll get x prime is equal to c2. Integrate again, x will be equal to c2x plus c3. This again, substitute in the assumption. U is equal to xt, c1, c2 plus c2x, sorry, c2x plus c3. This will give you that ax plus b. Constant with a constant are just another constant, correct? Okay, this is the first solution for you. The second solution, case 2, lambda is equal to positive beta square. So you'll get, just a minute, I have my notes with me. Okay, this will give you, sorry, I'm a bit lost. I don't like to scroll a lot. Okay, so this will give you, okay. X double prime minus beta square x is equal to 0. T prime minus beta square alpha square t equal to 0. Now, you need to use your formula sheet or use my method. You can use any of them. The formula sheet might be easier in some cases. Just try to understand my method just in case. Okay? So you get x is equal to C1 e to the power beta x plus C2 e to the power negative beta x. As for t, it's equal to C3 e to the power beta square alpha square t. Now substitute in the assumption x of t, and you will get that e to the power ae to the power. Again, same bases, so just we'll have the summation of the exponents. So beta x plus beta square alpha square t plus b e beta x negative plus beta square alpha square t. Okay. As for case 3, lambda is equal to negative beta square. Okay. So we'll get the following. Divide the page into 2. X double prime plus beta square x is equal to 0. X C1 sine beta x plus C3 cosine beta x. As for t, beta square alpha square t equal to 0. T is equal to C3e negative beta square alpha square t. Okay. As for u, substitute in the assumption. Just a simple multiplication, and you'll get a e to the power negative beta square alpha square t sine beta x plus b e negative beta square alpha square t cosine beta x. Okay, this is our second solution. Okay. Okay, now time for the boundary conditions. Now here my method, you can see it's different than the first one. Using the BCs, our boundary conditions, we would use these from here. Okay. Look, Mariam. Here again, you will understand that the solution is related to this variable, the variable that's here. Okay. This will give you that since the solution, since L and zeros are in this variable, disregard this because we have a value here. This will give you p of 0. Try to understand this, okay? Since most of the cases are in the x coordinate or in the x variable, this gives you that the answer is in x. Okay, that's the first thing. The second thing, since the answer is in the x, so you can, instead of using the function of u, you can use a function of x. So this function or this boundary condition can be rewritten to this following. The same thing here. This will be easier for you to operate. This one is not really important. I don't know how to use it and I don't want to use it, okay? You can use only the main important boundary conditions, which is x of 0 and x of L, okay? Okay, how this saying that my method is different? Well, you will see it here, starting with the first equation. And instead of using the function of u, you can use the function of x. As in case one, it won't matter because we have the same number of constant and variables. But you will see that it is very useful in the second two cases. Okay, as for x, you'll get, since we have x of 0 is equal to 0 and x of L is equal to 0, you'll get the following. So for case 1, using case 1 first, a of, or instead of a, c1 of 0 plus c2 is equal to 0. This gives you that c2 is equal to 0, correct? Again, rewrite the equation and you'll get that x is equal to c1x. Now substitute here, you get c1 of L equals to 0. L is not equal to 0. Remember that, okay? L is the length or the width, and it cannot be equal to 0. In this case, C1 is equal to 0. Rejected, because we have both both of our constants are equal to 0, hence the solution is equal to 0. Again, this means that our solution is rejected. Now again, go and do that in case 2. Okay, and you will use the x solution instead of the long one. Instead of u, you can see u has x and t and alphas and stuff. You just use x. Okay, x is easier. This is the second method that I'm using now. Okay, so x of 0, we have c1 e to the power 0 plus c2 e to the power 0 equal to 0. This is 1. This gives you that c1 is equal to negative c2. So x of L will get c1 e to the power beta L plus, instead of plus of c2, we'll use negative c1, okay? Because you see, from the first boundary condition, negative c1 e to the power negative beta L equals to 0. Now try solving this. The only way that this solution can be correct, only when c1 is equal to 0. Hence c2 is equal to 0. Try solving it. Okay, try solving it. You cannot. If you cancel the c2 and you added ln for both sides, you will end up with beta L. Okay, we'll end up with beta L negative beta L, which doesn't make sense. Okay, actually, no, it won't be like that, but still, it doesn't make sense. The solution won't make sense. Remember this, the solution won't make sense. So also case 2 is rejected. Try solving it if you don't believe me, but you cannot solve it. Now case 3. Here you will understand why I'm using this method. It's much easier here. This is case 3. This is the solution of case 3. So get x of 0, c1 sine 0 plus c3 cosine 0 equals to 0. Simplify this, you'll get c3 cosine 0 is 1 is equal to 0. Okay, now our new function is x is equal to c1 sine beta x, since this solution is now cancelled. Okay, now we'll find or we use our second boundary condition x of L is equal to C1 sine beta L equals to 0. Cancel the C1 by dividing both sides. You will end up by sine beta L. Remember, you must end up with sine beta L for both methods, my method and the doctor's method. Are you still here? Okay, cool. So sine beta L. For sine theta to be equal to 0, theta must be equal to n pi. In our case, theta is equal to beta L. So beta is equal to n pi over L. Okay? Now, finally, we need to use Fourier series. Fourier series. You will get Bn equals to 2 over L, 0 to L, B of 0 sine n pi over Lx dx. As for L, it doesn't matter to us. As for B of 0, it's actually one of the conditions given, and it's not called a boundary condition. This time it's called an initial condition, which is this. Remember them from the variables. X is not equal to 0, but t is equal to 0. This one is the initial condition. The initial condition does not have to be a single integer, doesn't have to be a constant. It can be a function. It can be 100x, maybe 103 over 5x square, whatever. Whatever is given in the question, it will be solvable. Okay, and I will solve a different type of initial condition in our next tutorial. And I'll solve it both methods. So you'll get 2 over L, 0 to L, 10 sine n pi over L x dx. 10 can be taken outside and you get 20 over L, and sine is integrated by negative L over n pi cosine n pi over Lx. Okay, 0 to L. Now to clear this, make it looking better, and you'll get negative 20 over n pi. L can be cancelled from both sides. Okay, and cosine n pi over Lx. 0 to L. Now just substitute the values of the intervals and you'll get negative 20 over n pi cosine n pi minus cosine 0. Okay, negative 20 over n pi, negative 1 over n, negative 1. Okay, try the n and odd test. If n is odd, you'll get 40 over n pi. If n is even, you'll get a 0. Eventually, we'll end up with this. The Fourier series is indicated as following: the approximation, odd, infinity, 40 over n pi, sine n pi over Lx. And this is our solution for the whole problem. You can see that it took us slightly less time, and you can see it's easier. Okay, to be honest, this method is actually more useful in our second tutorial because we're going to deal with second order by second order. And this will save you lots of trouble. Did you understand this method, Mariam?
Yes, I understood.
Is it easier from the first one?
Yes.
Okay, I will send you. See, I have actually I have a solved question, not this. Just a minute. I will stop the tutorial. Let me stop the tutorial and I will show you a solved question. Stop recording.